Today we're going to learn how to graph reciprocal functions. So here we have y equals 1 over x minus 3 plus 2. And so we're going to graph it by analyzing this function's end behaviors and asymptotes. And let's start with asymptotes. So we have two asymptotes in this function right here. And these two asymptotes come from two observations that we can make about the function. And the first observation is that x cannot equal 3. And x cannot equal 3 because if x did equal 3, then this would give us y equals 1 over 0 plus 2. And this right here is undefined. So we know that x cannot equal 3. Cannot equal 3. And so we can draw in an asymptote right here at x equals 3. Now let's think about what our function does at this asymptote. Well, if we had a number that's just greater than 3, we know that we would have a very small number, a very small positive number in this denominator. And so we know that 1 divided by a very, very tiny positive number would be a very, very big positive number. And so we know that as we get values that are closer to 3 but still larger than 3 for x, we would get a very positive, very big y value. So we know that from our right hand side of x equals 3, we're going to get bigger and bigger values as we approach x equals 3. On the other hand, if we were to take values that were very close to 3 but were like 2.999999, something like that, we'd get a very small negative number in the denominator of this fraction. And so we know that 1 divided by a very, very tiny negative number would be a very big negative number. And so we know that as we get values of x that are closer and closer to 3 but still less than 3, we would get a more and more negative number for y. So that is our first asymptote. Our first asymptote is x equals 3. Our second asymptote comes from the fact that y cannot equal 2. Y cannot equal 2. And this is because this fraction right here, 1 over x minus 3, can never equal 0. And this is shown because 1 over x minus 3, if we set this equal to 0, multiply both sides by x minus 3, we get 1 equals 0, which doesn't make any sense. So we know that we have a horizontal asymptote at y equals 2. So here is our horizontal asymptote at y equals 2. Let's think about if we had values of x that were very, very large, very positive and very large. So if we were to plug in a very gigantic value of x in right here, we would get that this fraction right here would be a very, very tiny but positive number. So we know that we would have 2 plus a positive, very small value. And we also know that if we were to choose a value of x that was even bigger, we would get a value that was 2 plus an even smaller amount. And so we know that this smaller amount would get so tiny that we would almost get 2 eventually. But we wouldn't get 2, we would get very, very close to 2. So we know that as we get bigger and bigger values of x, our function is going to approach y equals 2. It will always be bigger than 2, but it will never get to 2. On the flip side, if we were to put in very, very large negative values for x, we would get here a very tiny negative value for this fraction right here. And then if we were to add 2 here, we would get a value that was, again, very, very close to 2, but a little bit less than 2. And if we were to put in an even more negative, very big negative number, even bigger than the one that we put in before, we would get a value that was even closer to 2, but still not 2, and still less than 2. So we know that if we have very, very negative values of x, we're going to approach y equals 2, but we will forever be less than 2, since this fraction will always be a negative value. And so now we have our end behaviors here. We have this end behavior, that one, and that one. And we know that we will never cross this asymptote nor this asymptote. And so we can draw the function from here, but if we need any extra help, we can always plug in points. That's another great strategy to figure out if you've drawn all of your end behaviors correctly, or if you just want to make your graph more precise. And so if I were to put in x equals 4, so that I could make x minus 3 equal 1, I would get y equals 1 over 4 minus 3 plus 2. So y equal 1 plus 2 equals 3. I chose 4 because I knew it was going to be a nice number, and it is. So 4, 3 would be a point on this reciprocal function. So 1, 2, 3, 4, 1, 2, 3, right there. What happens if we had x equals 2? Well, y equals 1 over 2 minus 3 plus 2. And so this would be negative 1. Y equals negative 1 plus 2. And so that would be 1. So we also have the point 2, 1. So 2, 1. So now that we have a couple specific points, we can now draw a reciprocal function much easier and much more precise. And we can check that our end behaviors are correct. And so this would be how we would draw this function right here.